Okay, you have just finished watching the online lecture that gave you some information about different types of energy. And the three equations that you learned were for kinetic energy, 1/2 mv squared, for gravitational potential energy, mgh, and for spring potential energy, 1/2 kx squared, where k is the spring constant and x is the distance that you stretch it. We're going to go ahead and go through these three examples, so follow along and make sure that you are calculating your own calculations and then pausing and watching the answer so that it is genuine for you. Question number 1 says an 875 kilogram car speeds from 22 meters per second to 44 meters per second. What were its initial and final energies? So if we go ahead and identify some of these values, we have 875 kilograms, 22 meters per second, 44 meters per second. So the 875 kilograms is the mass, and the 22 meters per second is the initial velocity, and the 44 meters per second is the final velocity. We are looking for the initial and final energies, okay? So since the car is moving, we're talking about kinetic energy, so we're looking for initial kinetic energy and final kinetic energy. Okay, so this problem actually requires you to do two calculations, one for the initial velocity and one for the final velocity. So we're going to go ahead and do that. KE initial equals 1/2 mv squared. I'm going to make my marker a little bit thicker. And then plugging my values in, 1/2 of the mass, 875, times the initial velocity, 22. Don't forget to square it. Okay? And then you're going to plug that into your calculator. Pause here to make sure you put in this into your calculation and get an answer. And then play it again to get the answer. The answer is 211,750, and the unit is joules. Okay, it's a simple calculation. Now we're going to do the final kinetic energy final. We're going to use the final velocity to do that. So that's 1/2 mv squared, same equation. This time, mass is the same car, but now the velocity is 44 squared, okay? And so you get, go ahead and pause and calculate, you get 847,000 here. So what I want to point out with this problem is that the velocity from initial to final doubled from 22 to 44. The velocity doubled. But if you look at the kinetic energy did not double. As a matter of fact, the kinetic energy quadrupled. If you put that in your calculator, you'll see that 211,750 times 4 is exactly 847,000. And the reason why the kinetic energy didn't double but rather quadrupled is because in the kinetic energy equation, velocity is squared. So the change in velocity, which is 2, double, right? The change in velocity is also squared to give you a quadruple. Okay, the second problem says a slinky is stretched a distance of 3 meters, okay? If the amount of energy in the spring is 310 joules, what is the spring constant? So obviously this is spring potential energy. So I'm going to use the equation PE spring equals 1/2 kx squared. The distance is 3 meters. That's x, right? 3 squared. This is the amount of energy. So that's the spring potential energy. They're giving you the energy. They're asking for the spring constant, which is K. So we're solving for K here. Don't forget to square the 3. Solve for K. Pause and solve. You should get 68.89. Now, in your online lecture, you learned that the units for K are newtons per meter. Newtons per meter. Okay? This comes from somewhere. This comes from solving the potential energy equation for K. I'm not going to go through why it's newtons per meter. You don't have to worry about it. You just have to know that it's newtons per meter. Okay? So K is 68.89 newtons per meter. That's a pretty simple one. In class example number 3 says, if you lift a 2-kilogram book from the floor to a shelf 2.1 meters above the floor, what is the gravitational potential energy relative to the floor and then relative to your head if you're 1.65 meters tall? Okay, so let's draw a picture first. Let's see, I guess maybe I'll use orange here. Here you are. Make it better. Here you are. Okay. And there's a shelf above you. And there's a book on the shelf. Okay. There's the book. It's a pretty big book, but, you know, just go with it. The distance from your head, it tells you, actually, it tells you the distance from the shelf to the floor. Here's the floor. Okay. From the shelf to the floor is 2.1 meters. And it gives you the height of the person. And the height of the person is 1.65 meters. So the first question says, what is the gravitational potential energy relative to the floor? So let's do that. Let's say, how much potential energy does this book have relative to the floor? Let's calculate that. So we're going to do PEG. So this is for the floor. Equals MGH. So 2 is your mass times 9.8, that's G, times the height. So since it's relative to the floor, we're going to use 2.1 as the height. Go ahead and calculate that. Pause and solve. You should get for PEG 41.16 joules. There's a second question that says, what is the potential energy relative to your head if you're 1.65 meters tall? So relative to you, again, using the same equation, you just have to be careful about the height here. Okay, the mass is the same. We're still talking about the book. Gravity is 9.8. And now the height from the book to you. From the book to you is not 1.65, right? From the book to you is the difference between the two heights. So 2.1 minus 1.65. Okay, so if you actually calculate that, and we'll do this step by step, if you do the subtraction, you'll get 0.45 meters. That's the distance between the book and the head. And then go ahead and pause and calculate. So here you should get 8.82 joules. And it should make sense to you that this is a smaller number. If the book falls on your head from here, it won't hurt as much as if it were to fall on your toes from up here, right? Because there's a lot more potential energy that gets converted to kinetic energy when it falls to the floor. Okay? You are now going to use the remainder of your time to work on the energy practice problems fix-in. Let me point a couple things out to you here. The first two are fix-it problems, and I want you to know that the decimal was left out by mistake. That's not the fix, okay? So put the decimal in there and then try to figure out what's wrong with it. Fix it and then solve to see if you can get the right answer. Your answers should already be in there. If they're not, you can go ahead and write these down. These are the answers. For the last question, you've already had some practice with scientific notation. Be mindful that this is a number that's in scientific notation. You should know how to put that in your calculator at this point. When you do get an answer, you may get your answer in scientific notation. You may get an answer that's not in scientific notation, but you should be able to convert it to scientific notation with ease, since you've had some practice with that. So please spend some time on this fix-in and make sure that you really have a strong understanding of how to use the three equations. When we come back together the next time we meet, we'll talk about conservation of energy. Okay? Be good for the sub.